Alright, today we're looking at simple interest, which is exercise 1F. Now, we've got a formula here to calculate simple interest, but before we look at the formula, let's just look at what each part of it means. I is the total amount of interest. P is the principal. Now what that means is the amount that I borrow in the first place. R is the interest rate for each time period. Now the interest rate can vary depending on what the time period is, but whatever it is, N is the number of time periods that you have. N is the number of those. Now, given all of that, you can always work out simple interest by saying the interest is equal to the principal, that's the amount you borrowed, multiplied by the rate, multiplied by the number of time periods that the person has the money. Now, when we don't have any signs here, we know that these are notionally multiplication signs in between, because in algebra we don't write multiplication signs. Now, it makes sense that if you lend someone some money, then you're going to want all of your money back, but you might want some interest as well, and that's just like a little nice top-up for you, as if to say, well, thanks for lending it to me. So if you've borrowed some money, often you want to work out how much, or you've lent money, often you want to work out how much the interest is, but bear in mind that the total amount that the person will need to pay back is what they borrowed in the first place plus the interest. And a lot of people forget to add that back on. And depending on the type of question that you're looking at, you need to think about whether it needs to be added on or not. Now, just the very concept of interest. So let's look at an example. I lend a friend $120, so that's the principal, for 4 weeks at 10% interest per week. Now, let's think about what this really means. I want a little bit more back than what I've lent. What is 10% of 120? Well, you can type that in your calculator, 10% times 120. I can see that 10% is 1/10, and 1/10 of 120 is 12. So what I'm effectively saying is, sure, you can borrow my 120 bucks, but I want you to give me $12 a week for every week that you've got it. That's just what I'm charging for you to have it. Sounds a bit mean, doesn't it? But this is what banks do. If they lend you money, they want some interest. So if you've got that money for 4 weeks, you'll have to pay for lots of that $12. And 4 12s is 48. So the total interest should work out at $48. If you hang on to that money for 10 weeks at this same rate, you'll have to pay 10 lots of that $12. You'll be paying another $120 in interest. Along with the 120 you borrowed in the beginning, you'd have to pay back 240 total. So, how much interest does my friend pay? I've worked it out just in my head, using logic here, but I can throw the numbers straight into the formula. And so the interest is the principal. Now, I'd recommend writing this out every time, because if you write out I equals PRN at the start of every question, by the end of the exercise, you'll just know this, and you'll always know it. So we've got the principal, that's 120, times the rate. The rate is 10%. Notice I keep my percent in there. You've got a percent button on your calculator, so you may as well use it. Times the number of time periods, and here my friend is keeping the money for 4 weeks. Type all that into your calculator, and you should get $48. Check that you can do it now, and that you can get the right answer. Now, some of the questions in this exercise are going to require a bit of thinking before you get started. You can always use this formula, I equals PRN, but you might need to stop and have a think about how to apply the formula based on the scenario. So, for example, if I invest $60, I'm putting that into a high interest savings account that gives me 5% interest, I should have written in there, per annum. Now, we didn't use that terminology before. Per annum is a really common one. It means per year. Annum is just Latin for year. How long will it take, and I should write here in years, for my money to double? All right, so we need to think here. We want our money to double. That means if we're putting $60 in, we want it to get to $120. Now, that's not going to happen until we've earned ourselves $60 more in interest. Because that way we'll have the $60 that we put in plus the $60 interest that we've earned. So here I know what the interest needs to be, 60. So I'm going to put in that. I know what the principal was also, 60. And I know what the interest rate is, so I can multiply by 5%. What I don't know is how long. I don't know how many years I'm going to have to keep my money in there for this to happen. So I'm just going to write times n because I don't know what n is. All right, now we can tidy up. We can't do this whole part on our calculator because we can't put n in there. But we can do 5% of 60. What happens if you put in 5% of 60? Well, that should be 1/20th of 60. It should be 3. So this side is still 60. I'm just going to leave that like that. And this side now I've got 3 times n. So I effectively just tidied up this part and found that it was 3. Does that make sense? All right, now we need to solve for n. That means we need to get the n by itself. So look at what's happened to this n. We've got n times 3. How do we undo multiplying by 3? We need to divide by 3. So if we divide this whole side, let's use blue, this whole side of the equation by 3, we need to divide this side by 3 too to keep it balanced. Now if I've got n but I times it by 3 and divided it by 3, obviously those 3's go away and now I've got the n by itself. That's why I did it. But I had to do the same thing to this side to keep it balanced, and now I've got 60 divided by 3, which is 20. Goodness me, 20 years is a long time for that $60 to be sitting in there before it doubles. I don't think that's a very good interest account. I might choose something better to do with my money. Now, most banks do not use this method of interest. They use compound interest much, much more. And we're going to learn about that next lesson, and that will give us some scenarios that are a little bit more realistic. But before we can look at compound interest, we need to understand how to calculate simple interest.